so that you know. Okay, so lesson number 5 is solving inequalities in two variables using technology. So this is actually stuff we've all already covered. So all it is that it's notes about how to solve these problems using your calculator, which we've been doing all along, right? That's how we want to start every question. So if you ever forget how to do this when you're doing your homework or studying, go to lesson number 5 to look at it. So if we go to example number 1, we remember that when we are graphing something, we always want to make sure that it's in the y form with the y by itself. So even if you get something that looks like this, you have to be able to put it into that form. So I'm going to add 12. So we get 2x plus 3y is less than negative 12. Subtract 2x from each side, giving us 3y is less than negative 12 minus 2x, or positive 12 actually, because we added 12 to both sides. And then we want to divide by 3, like that. And so we get y is less than 4 minus 2 over 3x. So then when we're graphing this, we get to go 4 minus, and remember to put those coefficients in brackets if they're a rational number, x. And because it's y is less than, we're going to make it a less than, like that. So y is less than 4 minus 2 over 3x. And we graph it to get something like that. You could do that. Okay. So we know that we would get something that looks like that. Do you have an x in there? Okay. So anytime you don't have an x, this is just a number, right? And so then you'll get a straight line across. Okay. So because we already know how to graph things in our calculator and solve these problems graphically, this is all we're going to do for lesson number 5. We get to omit all the homework for lesson number 5.
Omit all.
Okay.
Omit all. Omit all. Say omit all.
Okay. So we'll go. Oh, that's my key. We'll go. Homework. Omit all.
Yeah! Yeah! Oh, I should have got money on this.
Okay. So moving on to lesson number 6. We said this is a 2-lesson day. So that was lesson number 5, our first lesson we finished. So now we're on page 535. Okay, so today is a little bit different because we're doing what we call case analysis. Okay, so everything we kind of did before involved like having an entire solution region like that. Today, our solutions are going to be just a piece of the graph, like that. Okay, so when we're looking at a graph like this, so this is the graph of x squared plus 2x minus 8. We know that, okay, when we have that, what am I looking at? X squared plus 2x minus 8 is greater than 0. That's the part of the graph where the y is greater than 0. Okay, so that would be this part of the graph. Right? And so all of these x's here, and here, would make all of these y's here. And these are all the y's that are greater than 0. So all these x's here and here, make y's that are greater than 0. Okay? They make y's that are greater than 0. Okay, so yeah, so even if we have like -10, it's going to make a y that's way up here. Okay? So then the other half of the graph we say is, well, x squared plus 2x minus 8 is less than 0. So that's when all the y's are less than 0. So it becomes that part of the graph. Okay? So all these x's in between here make the part of our graph that's negative or less than 0. Okay? So the important part of these graphs really are our x-intercepts, right? This is where things change on us. So here we have 2 and -4. So we know if we go down here, we can say, okay, the solution to the inequality is greater than 0. So we can say the inequality is positive when x is less than -4 or greater than 2. Okay? Just like we see here, okay, when x is greater than 2, it makes our graph go above the x-axis. When x is less than -4, it makes our graph go on the positive side. Kind of, yeah. And so the opposite, so we have the solution to the inequality is negative, so it's below 0. We know that that's going to happen when x is between 2 and -4. Right? So all the space in between here makes our graph dip into the negative y's. Okay? So we write that like x is between -4 and 2, so x is greater than -4 or less than +2. Okay? And one thing to notice is that because these are just greater than and less than, not equals, we'll keep these, that's not good, these here also as just greater thans and less thans, not including the equals. So our signs always kind of have to match up with here. If we have a line under here, our solutions need that equals as well. Okay? So, and a couple questions on your homework, and so you need to know how to do it on a number line. So the first one where it's greater than 0, we know that this is the part of our number line that would have that. And so when you're doing these, you can even draw like a little sketch of the graph, and then you look at it and you say, okay, well, that is that, right? And because it's not equal, we know that we're going to have open circles here. Okay? And then same for this one. We say, okay, when the graph is less than 0, we know that that's this part here, so it's going to be this part of our number line. Okay? So, if you get a problem, and so there's kind of two main types. The one says use the graph of the function to solve the inequality. So, because they say use the graph, you know, even though normally we want to graph first, that you definitely want to graph it first. So we'll go 12 plus 4x, actually 12 plus 4x minus x squared. Okay? And I'm just going to adjust the window so we can see the entire thing. I'll go plus 15 because I know my y-intercept is 12. Exactly. So should we go 25? 20? Beauty. Okay, so you can draw a picture of this in your notes, just like I am. There you go. I'm sure yours looks as good as mine. Okay. So then you look at this and you say, okay, so they're looking to solve where 12 plus 4x minus x squared is greater than 0. So we know that is this part of the graph here. So if this was a multiple choice question, I would make my y2 equal to 0. And I'd find my x-intercepts. Enter, enter. I don't know. Oh, do I? Oh. Well done, techie.
For that, we can omit the rest of the whole.
No. Okay, so we know that our one x-intercept is -2. And then our first one, or our other one, we want to go all the way over. That. Scoot all the way over. And then we know our other one is 6. Okay? So, Andrew, focus. Okay? So we know that, okay, if this is a multiple choice question, we'd say, okay, our graph is above 0 or positive between -2 and 6. So I go when x is greater than -2 and equal, because it's like that, and less than or equal to 6, that's our solution. Okay? If it's a long answer, we know that we would want to factor this algebraically. So we'd go -x² plus 4x plus 12. We'd go, okay, what plus what is equal to 4? And what times what is equal to -12. Awesome. So you get 6 and -2. So you go -x² plus 6x minus 2x plus 12. We do our normal type 2 where we find the common factor between the first two terms. We get x minus 6. And then x minus 6 again. So our two factors are -x minus 2 and x minus 6. So we know x is equal to -2 and x is equal to 6. Okay? So, yes, Daniel? It's kind of like it's neutral, right? So when it's greater than and equal to, we consider it part of our solution. If it's not, if it's just a greater than, we say like everything above 0 is part of our solution. Okay? So then they ask us to draw the solution on a number line. So we go -6 or -2 and +6. Okay. So we say when x is greater than -2 is right there, going all there. When x is less than 6, it goes that way. And then the overlap, it's our solution set exactly. That would be sweet. Yes, exactly. So on a number line, because it's equal to, we would be looking for filled in circles like that. Okay, guys, focus. Okay, and then so, Sam? So our next one is when it's less than 0. So we could say, okay, well, that's this part here. So it's basically going to be the opposite of what we found before. We know that it's when x is less than or equal to -2, and when x is greater than or equal to 6. Okay? So, you can flip the page. Okay, so on the next page, the other type of question is like a case analysis question. So I want you guys to write case analysis right here. Okay, so normally in the question they'll actually say solve using case analysis. This one they don't. Solve by case analysis. Okay. Yeah. And you guys will definitely want to write this down. Justin, who's not taking any notes. That explains a few things. Okay, so Andrew, you should take notes as well. Okay. So we know that when we encounter any question, that we should graph it first. So that's exactly what we're going to do. We're going to go x squared minus x minus 20. They do, but because we're just looking at the line and not the shaded region, we don't want to use them. Okay? So if it's a shaded region question, absolutely. These ones, not really, because we're getting too much information and chances are we're going to get a little confused. Okay? So we know our y-intercept is negative 20, so I'm going to make my y-min negative 25. Okay? So you'll want to draw a picture of this. And draw it on your paper like that. So we get to say, okay, when this equation is less than 0, it's this part right here. Okay, so we know it's going to be all of these x's here, because all of these y's here are less than 0. Okay? I wouldn't, because we're just looking at the graph, right? Yeah. Okay, so